This is one of the longest reviews I've ever seen, so I might kind of zip through it. Okay, number 1 and 2 said that I can use the Pythagorean theorem. So I'm noticing here on this first triangle, I have an unknown leg. So it's 5 squared plus b squared equals 14 squared. And, you know, I'm going to subtract the 5 squared from both sides. A lot of what I did here, I just kind of popped into my calculator. Just don't forget to take the square root of both sides. I want b, not b squared. So the measurement from over here was 13.1. This one also, I'm looking for a missing leg. So these are my legs. This is my hypotenuse. X squared plus 30 squared equals 34 squared. So same idea. Awkward pause. And once again, don't forget to take the square root of both sides. Number 3, true or false? A triangle with side lengths of 6, 8, and 11 is a right triangle. So I put these in the Pythagorean theorem and see if it works. If 6 squared plus 8 squared equals 11 squared, then it's going to be a right triangle. So 6 squared is 36, and 64, and 121. When I put this part in my calculator, it's 100. And 100 does not equal 121, so this is not going to be a right triangle. Yeah, I can define the Pythagorean triples. So Pythagorean triples, I can show you an example of one up here. 16, 30, 34 is a Pythagorean triple because they are a right triangle and they are whole numbers. 5, 13.114 is a right triangle, but they're not whole numbers. This is not a whole number, so it's not a Pythagorean triple. Pythagorean triples are whole numbers. So I'm going to check this one again. 9 squared plus 40 squared was 1,081. And 41 squared was, 16, was also 1,681. So yes, a squared plus b squared was c squared. All right, number 5. 10, 24, 26 is known as a Pythagorean triple because 10 squared plus 24 squared equals 26 squared. That is true. That's what makes it a Pythagorean triple. So 2 sets of Pythagorean triples. You don't have to look very far. We've got one there. We had one up here, 16, 30, 34. The most popular one is 3, 4, 5. Everyone knows that one. Some examples of non-Pythagorean triples. All right, down here, which trig ratio is defined as opposite over adjacent? This is sine. Oh, that's a lie. Tangent. Adjacent over hypotenuse is cosine. Sine is opposite over hypotenuse. Sine again is opposite over hypotenuse. And the study of angle theory is known as trigonometry. In ABC, write the sine, cosine, and tangents. Okay, so it's talking specifically about angle A. So we're going to put a theta up here. So opposite, adjacent, hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And these are the reciprocal. So I'm taking these and I'm flipping them upside down. I can identify special right triangles. Yes, we did study 45, 45, 90. Okay, if the medium leg is 6, then the short leg is 2 times the square root of 3. Well, I have to divide it by the square root of 3 to figure it out. So upon inspection, these do not look the same. But if I multiply by my super one, which would reduce to 2 times the square root of 3. The blank special right triangle uses the square root of 3. It's the 30, 60, 90. We've got a short leg, 2 times the short leg, and the short leg times the square root of 3. The hardest part of these was maybe drawing them. A is the right angle, B is 45, so this is also, oops, C is, 45, 45, and B is 15 feet, and they want you to find BC. A lot of people used cosine. A lot of people use that. I use the rules, so I know that the leg times the square root of 2 on 45, 45, 90. So I have this answer. If you did cosine, you're going to have 21.2. So again, this picture, angle E is the right. F is 45. This is 45. This is G. EG is 23 feet. If it's 45, 45, 90, this is 23 feet also. They want us to find EF. So if you don't remember that they are the same, you can use a Pythagorean, you can use tangent, cotangent, sine, something. So maybe you don't know this one. You could do tangent 45 is opposite over adjacent. I was kind of looking at that one. So you'll still get 23 though, 23 feet. Whoa. B is 30, C is 60, and they're telling us that AC is 7 feet, and they want us to find AB. So if you know the shortcut, that's 7 times the square root of 3. This would be 14, although it didn't ask for it. If you don't know the shortcut, you can do tangent of 60 equals opposite over adjacent. You won't get 7 times the square root of 3, though. It would multiply it together. So let me grab a calculator. 7 times the square root, times the square root of 3. 12.1. Okay, on these ones, I like to draw the pictures and label. So this is opposite over adjacent. Cosine is opposite over hypotenuse. Secant is hypotenuse over opposite. So I'm going to use this given to draw my triangle. Opposite, adjacent. I did the Pythagorean theorem, and I found that this missing side was 41. So when it says I want the cosine, it doesn't want you to put anything in your calculator. It wants the fraction. Cosine of theta is opposite over hypotenuse. And my equation here says to square it, and plus 3. And then you don't put anything in your calculator for that cosecant. It wants the fraction, the hypotenuse over the opposite. So label everything really well on these. It's just filling in the blanks. And then when you put that all into your calculator, I got 14.6. Okay, the next here is the same. So they're giving me this if the sine is, again, opposite over hypotenuse. Can't always have tons of apples. I'm going to use this beginning information. Opposite is 3. Hypotenuse is 5. This is a 3, 4, 5. This is a Pythagorean triple. The cosine of 4 and 5 fits into that picture of my triangle. So I'm trying to find tangent. So tangent of theta will be opposite over adjacent. All right, if cosine, always have some ornery horses. So when drawing my triangle, the adjacent is 12, the hypotenuse is 13. This Pythagorean triple is on the board, but if not, you could do the Pythagorean theorem. So sine is opposite over hypotenuse. All right, number 22. I can use trig ratios to find missing sides. I know adjacent. I know the hypotenuse. So it would make the most sense to use the cosine. Adjacent, hypotenuse. So to solve these, we need to get the x in the numerator. So I'll have x times the cosine of 62 equals 10. And I can divide both sides by cosine 62. Those cancel. So put this in your calculator. I got 21.3. And looking at this triangle, that makes sense with the 10, and the hypotenuse should be the longest side. Okay, pictures. An extension ladder leans against a building, forming a 65-degree angle with the ground. The base of the ladder is 4 feet from the building. How long is the ladder? So I know adjacent, and I want to find hypotenuse. Cosine would make the most sense. Just like the problem before it, in order to solve this, I need to get my x's in the numerator. And then I can divide both sides by the cosine of 60. So to get your answer, 4 divided by the cosine of 60 is going to be our x. I got 9.5. Feet? I don't know. Oh yeah, it is feet. More ladder problems. The directions for the use of a ladder recommend that for maximum safety, the ladder should be placed against the wall at a 75-degree angle with the ground. If the ladder is 14 feet long, how far away from the wall is it?
Kate Little Walker, please come to the counseling office. Kate Little Walker.
So I've got adjacent and hypotenuse again. But this time our x is already in the numerator, so it only requires one step to solve. So 14 times the cosine of 75 will tell you x, and it says 3.6. All right, a 24-foot ladder leaning against a building forms an 18-degree angle with the side of the building. How far is the base of the ladder from the base of the building? Okay, we have opposite and hypotenuse, so it's sine. This is one step. If I'm going too fast, push pause at any point in time. To solve, I can multiply both sides by this 24. 24 times the sine of 18 X is 7.4. I just pushed pause and took a break. This is a very long review. If you need to take a break, take a break. Okay, another ladder problem. Honestly, if you know the other three ones, I would just not even worry about this one. You've got the gist. Okay, a ladder is 14 feet long, rests against the side of a building. The base of the ladder rests on level ground, 2 feet from the side of the building. What angle does the ladder form with the ground? We know adjacent. We know hypotenuse. We don't know the angle. So adjacent hypotenuse is cosine theta. Oh, so I lied a second ago. This is a slightly different problem. You're finding the angle. Adjacent over hypotenuse. So if you recall, we don't divide by cosine. If you type into your calculator 2 divided by 14 divided by cosine, it's going to be weird. It won't make sense. So the inverse of cosine is cosine negative 1. We do that on both sides. So you type that in first. It'll start like this. And you can do your 2 over 14 and enter. This is what's going to give you that answer, is doing cosine negative 1 to both sides. I got 81.8, which makes sense for an angle. It's actually huge, right? This one's going to be small. So really, it's like 2 feet and 14 feet. This is a very obtuse angle. My picture is not very accurate. Okay, a road rises 10 feet for every 400 feet along the pavement. So the pavement, this is how I started my drawing. Here's the pavement. And it's rising just 10 feet, so I'm going to exaggerate that a little bit. What is the measure of the angle the road forms with the horizontal? This is my horizontal. This is my road. So I believe the angle it's referring to is this one. And I have opposite, and I have adjacent. So I'm going to use tangent. How do you find theta? Well, I'm going to use the tangent inverse on both sides. Type in this first, then the 10 over 400, and it's a tiny angle. We're not surprised that it's, well, maybe you were surprised that it was 1.4. Okay, a kite is held by a tight string pegged to the ground. Here's my peg. The string is 40 feet long, and it makes a 33-degree angle with the ground. Supposing the ground is level, find the vertical distance from the kite. All right. Sine. I know the opposite, and I know the hypotenuse. Opposite and hypotenuse is sine. I love when the denominator is the 40. It's one step to solve. Let's put that in our calculator. If at any point I'm going too fast, you just pause. Work ahead of me. Check your answer. Okay, find the value of x and y. I know my rules for 30, 60, 90. So I know that the short leg is going to be half of the long leg, and the medium leg will be 2 times the square root of 2. Oh, 3, sorry. But if those aren't familiar to you, you can use your trig functions. So I could say sine of 30 degrees is x over 4. And I could say cosine of 30 degrees is y over 4. And it would give me, well, it won't give you 2 times the square root of 3. It'll tell you like 3.5. It'll put it into a decimal. But you'll get a 2 for your opposite side. Find the sine of b, the cosine of b, and the tangent of b. So I focused on b, hypotenuse, opposite, adjacent. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So I'm just looking for those fractions. Okay, I can apply trig ratios to the real world. Angles of elevation and depression have the same measure. This is what that's talking about. Here's the horizontals. Here's an angle of elevation. Here's the angle of depression, and they are alternate interior angles, so this is true. The angle of depression is used when you are sad. No, wrong use of the word. The angles formed when looking up, elevation. So here's a small plane, it's flying at altitude a half mile. Begins its descent. When it is 13 ground miles, I'm glad it's specified. What is the angle of depression of the descent? This is my weakness. This is the angle of depression. And we just talked about on number 31 that that's equivalent to this one. So this is going to be my theta. And I'll use tangent equals opposite over adjacent. And the angle that I got was 2.2. So that seems so small, but I mean, my picture's not accurate. Half a mile and 13 miles, it's going to be tiny. Okay, a snowboarding slope with a vertical drop. What is the angle of depression? Okay, angle of depression again is this guy, which is equivalent to this one. So I know opposite and hypotenuse. Plug it in. You could probably round that to 14 degrees. Okay, I think when I finally did this one, I think this is unnecessary. You guys can decide what you think about my picture here. Evan made 2 model rockets and launched them on a calm day. His eyes are 6 feet from the ground. Evan stands 450 feet from this rocket, B, and the angle of elevation, I guess he's looking up at it, is 62.2. What is the altitude of the rocket? This is how I picture it. I'm not sure. What didn't I write? 450 feet. All right, so I can use tangent. Is opposite over adjacent. And I need to grab my calculator because I didn't finish this one. I thought I had to do something with that 600 to 1200. I just don't feel like you need to. So tomorrow we can talk about it. You can tell me if you disagree. Oh, I just remembered I can't do trig functions with that calculator. It's stuck in radian. 450. I'll multiply both sides by 450. Oops. 62.2. Okay, so it's 853 feet. I've got to add on the 6 feet from the height of the man. All right, good luck.